At 2 in the morning, the desert should be cooling down, but parts of Dubai remain warmer than the land beyond the city. The sun is gone. So what is still heating the streets? The most disturbing source of heat may not be above Dubai. It may be humming behind its walls. A massive network of machines is working tirelessly to keep the indoor world freezing cold. But every ounce of heat they remove has to go somewhere. And that somewhere is right where people walk. To understand why Dubai cannot cool down, we first have to enter the places where it feels impossibly cold. We have to look at the artificial winter built inside the desert. This is not just a story about weather. This is a story about what happens when a city tries to outsmart nature and accidentally builds a trap. Welcome to the invisible machine of Dubai. The city did not adapt its life to the desert. It built a second climate and placed that climate indoors. When you step into a luxury mall, you are immediately hit by a wall of chilled air. It is a fabricated winter in the middle of a barren landscape. Shoppers walk around in light jackets, while the temperature outside sits at a blistering high. Hotels feature expansive lobbies with marble floors that feel like ice to the touch. The metro stations act as refrigerated capsules suspended above the glowing asphalt. Even the cars are mobile coolers, shielding their drivers from the harsh reality of the sun. The scale of this engineering marvel forces a sense of awe. You look at the glittering skyline and think that human ingenuity has truly conquered the elements. The entire metropolis feels like a testament to absolute control. Millions of square feet of real estate are kept at a constant 20 degrees Celsius. A single droplet of condensation sliding down a glass window reveals the stark contrast between the two worlds. But this illusion of control hides a massive thermal debt. We are trained to think of cooling as the destruction of heat, but heat cannot be destroyed. The laws of physics demand that energy is merely transferred from one location to another. The air conditioning systems are constantly extracting thermal energy from the indoor spaces. They gather all the heat generated by human bodies and electronic devices, and solar radiation piercing through the glass. Then they push it somewhere else. The sheer volume of this displaced energy is staggering. It creates a completely different environment just beyond the revolving doors. Tourists flock here for the pristine indoor experiences. But the tourism industry is quietly facing a crisis. Visitors step outside to admire the architecture and are immediately suffocated by an unnatural wave of warmth. The outdoor walkability is rapidly disappearing. And that raises a profound question. Where does all the heat removed from those thousands of cold rooms actually go? Sand can heat rapidly, but it can also lose heat rapidly. A dense city absorbs radiation across thousands of surfaces and releases it long after sunset. Researchers have measured this phenomenon extensively. Air temperatures in the urban areas of Dubai are significantly higher than in the surrounding rural desert. The average urban heat island effect here creates a temperature difference of about 1.3 degrees Celsius, but that is just the daytime average. The true intensity reveals itself in the dark. During the night, the urban heat island intensity averages around 3.3 degrees Celsius. Wind patterns and meteorological conditions constantly influence these numbers, but the underlying reality remains unchanged. The city operates like a gigantic heat battery. We can break this down into 3 simple concepts. First, there is absorbed heat. Throughout the day, the asphalt and concrete and stone soak up the relentless solar radiation. They drink in the sunlight like a sponge absorbing water. Second, there is stored heat. Because urban materials have high thermal mass, they hold on to this energy tightly. They trap the warmth deep within their structures, preventing it from dissipating into the atmosphere. Third, there is released heat. As the ambient air finally begins to cool in the evening, the buildings and roads start to exhale. They radiate all that trapped energy back out into the streets. This thermal fingerprint is undeniable. You can feel it through the soles of your shoes as you walk along the promenade. It is a silent and invisible process that transforms the urban geometry into an oven. The physical footprint of the city ensures that the heat has nowhere to escape. It bounces between the tall structures and lingers in the narrow corridors. Tourists who hoped for a pleasant evening stroll find themselves sweating uncontrollably. The luxury experience promised by travel brochures evaporates the moment they leave the climate-controlled zones. This growing discomfort poses a very real threat to a tourism model built on outdoor spectacle. But stored sunlight explains only part of the heat. Dubai also manufactures heat of its own. An air conditioner is a refrigerator with the cold side indoors and the hot side facing the city. Imagine opening your refrigerator door and leaving it open in the middle of your kitchen. The inside of the fridge is cold. The coils on the back are incredibly hot. Leaving the door open cannot cool the kitchen down. The compressor has to work harder, and the total amount of heat in the room actually increases. Every compressor is a small machine with one job, and the very act of consuming electricity generates even more thermal energy. This creates a ruthless cycle known as the cooling feedback loop. The hotter the outdoor environment becomes, the harder the building must work to stay cool. The harder the building works to stay cool, the more waste heat it ejects into the street. The more waste heat is ejected into the street, the hotter the outdoor environment becomes. This loop is a perfect demonstration of thermodynamic principles that no amount of money can bypass. Scientific models coupling building energy use with atmospheric conditions reveal a disturbing trend. Anthropogenic heat from air conditioning can significantly amplify the nighttime urban heat island effect. It forces the surrounding air to maintain high temperatures. This in turn drives up the cooling demand for the next day. The compressors spin faster and louder. They draw more power from the grid and expel more hot air into the public domain. It is a relentless mechanical heartbeat that pumps heat instead of blood. People outside are forced to navigate through these invisible rivers of expelled thermal energy. The outdoor environment becomes a dumping ground for the luxury enjoyed inside. We are not saying that air conditioning is the sole cause of the urban heat island. The pavement and the glass and the cars all play their part. But the mechanical cooling systems act as an aggressive amplifier. They take a naturally hot climate and inject it with a continuous stream of concentrated artificial heat. Let us look closely at Dubai Marina. It is a marvel of modern engineering and a premium destination for tourists worldwide. But it is also a perfect example of a city designed like a heat battery. The density of high-rise towers creates a spectacular skyline. However, this same density blocks natural wind flow and traps thermal energy. The materials chosen for these structures are highly reflective or highly absorptive. Glass facades reflect the harsh sunlight down into the streets. Asphalt roads absorb the radiation and hold it tight. Concrete structures act as massive thermal reservoirs. There is very little continuous shade for pedestrians. The walking paths are interrupted by wide roads dominated by motorized traffic. The cars themselves act as mobile heat generators, pumping exhaust and engine warmth into the heavy air. The entire artificial skyline is a monument to human ambition. A short stretch of unshaded sidewalk becomes completely unwalkable by noon. You can see a constant stream of hot air blasting from a condenser unit mounted on a lower wall. The thousands of chilled apartments above demand a sacrifice at the ground level. Even the water bodies in the marina play a complex role. Depending on the wind and urban geometry, it can sometimes increase humidity, making the heat feel even more oppressive. The city looks cold from behind glass. At pavement level, it is breathing out everything the glass keeps away. This dynamic is slowly damaging the very appeal that brings visitors here. A tourist destination that cannot be comfortably explored on foot is a destination facing a subtle crisis. The beautiful promenades become empty concrete deserts during the hottest parts of the day. The structural design of the neighborhood guarantees that the thermal energy cannot escape easily. The heat bounces between the luxury towers and settles heavily over the canals. The environment is not just receiving heat from the sun, the city is actively producing its own heat. The worst evidence is not what happens at 2 in the afternoon, it is what refuses to stop happening at 2 in the morning. When the sun finally sets, the vast natural desert outside the city limits begins to cool down rapidly. The sand releases its heat into the night sky, and the temperature drops. But inside the urban core, the story is entirely different. The concrete and the asphalt and the glass are still holding on to the solar radiation from hours ago. The motorized traffic is still flowing, and most importantly, the mechanical cooling systems are still operating at full capacity. The threat here is not a brief spike in daytime temperature. The real threat is the gradual loss of the nighttime recovery period. Nighttime is when an urban ecosystem is supposed to heal. It is the crucial window when surfaces should cool down and the air should clear. But the continuous operation of thousands of compressors denies the city this recovery. You can hear the relentless hum of the machines vibrating through the narrow alleys. You can feel the hot exhaust pushing against your skin in the dark. This prolonged nighttime heat is exhausting for the human body. Every degree that remains in the air has to be paid for again the following afternoon. The structural heat battery never fully discharges. It just gets topped up again when the sun rises. This creates a compounding effect, where the baseline temperature slowly creeps upward. The inability to cool down at night transforms a challenging climate into a punishing one. The tourism industry relies heavily on vibrant nightlife and evening outdoor dining. But when the midnight air feels like a heavy, damp blanket, the appeal of outdoor terraces vanishes. Restaurants are forced to enclose their patios and pump in even more conditioned air. This just adds another layer to the relentless cooling loop. The city refuses to sleep, and the machines refuse to stop breathing. The thermal debt continues to accumulate in the shadows. To truly understand the scale of this thermal debt, we have to shift our focus from temperature to power. The artificial climate is entirely dependent on a massive electrical infrastructure. The data from the Dubai Electricity and Water Authority for the year 2025 paints a clear picture. The utility company produced an astonishing 62.21 terawatt-hours of electricity. This represents a 5.10% increase in production compared to the previous year. The peak load capacity reached 11.39 gigawatts. That peak load grew by 5.83%. The system now serves over 1.3 million customer accounts. These numbers are staggering. The authority identifies the highest electricity usage hours during summer as typically falling between noon and 6 in the evening. This is when the battle against the sun is at its fiercest. It is just one person lowering their thermostat by a single degree, but when that action is multiplied across hundreds of thousands of rooms, it becomes a massive system load. Each tower is cooled individually, but the consequences are paid collectively through the grid, through the streets, and through the air surrounding the city. The entire electrical circulatory system is strained to maintain the illusion of winter. We must be careful not to attribute all of this power consumption solely to air conditioning. Population growth and construction and economic activity all drive up the demand. This is not evidence that the grid is collapsing. The infrastructure is robust and highly managed. However, it highlights the sheer volume of energy required to sustain this specific model of urban life. Every megawatt of power consumed ultimately degrades into heat. The electricity flows through the wires and powers the compressors and ends up as thermal energy pushed into the atmosphere. It is an invisible tax levied on the environment. The more the city grows, the higher the tax becomes. A marble lobby can be chilled to 20 degrees, but the delivery rider outside cannot invoice the building for the heat it just expelled. This brings us to the human center of the engineering system. The divide between the indoors and the outdoors creates a stark landscape of thermal inequality. Inside you have the pristine hotel lobbies and the sprawling malls and the glass-walled apartments. These private spaces are heavily subsidized by energy to remain perfectly comfortable. People with means can seamlessly move from an air-conditioned home to an air-conditioned car to an air-conditioned office. They experience the city as a series of disconnected cool islands. Outside you have the maintenance workers and the delivery personnel and the security guards. You have the pedestrians and the people waiting at bus stops. They are the ones who must navigate the public microclimate. They bear the brunt of the concentrated solar radiation and the artificial heat ejected by the buildings. The private sector hoards the comfort while the public space absorbs the thermal waste. The United Arab Emirates does maintain strict occupational heat stress prevention policies. This includes a mandatory midday break for outdoor workers from mid-June to mid-September. This policy acknowledges that the outdoor heat is a severe occupational hazard, but the systemic paradox remains intact. The very technology used to protect people inside makes the environment more hostile for those outside. The distribution of comfort is wildly uneven. Tourists walking between attractions suddenly find themselves on the wrong side of this thermal divide. A short walk to a nearby restaurant becomes an exhausting ordeal. The outdoor public realm is being sacrificed to maintain the indoor private realm. Dubai can continue buying colder rooms. The harder question is whether it can buy a colder city. The stakes are getting higher. The Dubai 2040 Urban Master Plan projects massive expansion. The resident population is expected to reach approximately 5.8 million people. The daytime population could surge to around 7.8 million people. This is a staggering amount of human activity to integrate into a fragile desert ecosystem. The logic of the feedback loop is simple and unforgiving. More residents and more activity mean more floor space. More floor space demands more services. This directly leads to an increased cooling load. That requires more energy infrastructure and results in more waste heat that must be managed and expelled. We are not saying that population growth inevitably leads to absolute disaster. The critical question is not whether Dubai will continue to grow. The question is, what type of urban form Dubai will use to grow. If the future relies on the same heat-absorbing pavements and isolated towers dependent on mechanical cooling, the problem will escalate. If the pedestrian spaces remain unshaded and mobility remains entirely dependent on cars, the cooling loop will only grow stronger. The energy costs will rise, and the outdoor environment will become even more alienated from human comfort. We see similar patterns in Riyadh and Doha and Phoenix and Las Vegas. These are all hot cities becoming increasingly dependent on artificial cooling. The tourism crisis will deepen if visitors realize that the city is only habitable behind glass. The loop is powerful, but it is not a law of nature. It is the result of design. Dubai needs an urban fabric that produces less heat in the first place. The solution is not just better air conditioners. The solution is preventing the heat from penetrating the buildings. This begins with external shading and climate-appropriate materials. Better insulation and carefully designed reflective surfaces can drastically reduce the thermal load. Continuous shade for pedestrians and optimized wind corridors can make the streets livable again. Reducing the area of exposed asphalt is absolutely critical. We must also look at green infrastructure based on actual performance. Trees should be prioritized for their ability to cast wide canopies of shade. Furthermore, centralized cooling offers a path forward. District cooling systems can reduce the electricity used for cooling compared to thousands of individual standalone units. Dubai has a clear goal to raise the share of district cooling from about 25.6% in 2021 to 40% by 2030. But we must understand the limits of this technology. District cooling does not make heat vanish. It simply manages and expels the heat more efficiently on a centralized scale. The design of public spaces must evolve. We need covered walkways and shaded rest stations. Fast access to public transit and paving materials that retain less heat are essential. We must measure temperature and humidity and radiation at the height of a human body, not just on rooftops. Modeling studies in Dubai suggest that combined urban heat mitigation strategies can significantly reduce cooling energy demand. The results vary based on building type and intervention configuration, but the potential is real. Dubai has built millions of rooms where the desert is no longer allowed to enter, but the heat removed from those rooms has not disappeared. It waits on rooftops. It gathers between towers. It settles over the pavement after dark. Inside the city, sleeps beneath blankets. Outside, the machines keep breathing. The massive network of compressors hums through the night. The exhaust fans push the hot air down into the empty tourist promenades. The distant natural desert has long since surrendered its heat to the cold sky, but the mechanical oasis refuses to let go, and long after the sun has vanished, Dubai is still heating itself. This documentary distinguishes measured conditions from modeled mechanisms and future risk scenarios. Air conditioning waste heat is one contributor to urban heat, alongside solar radiation and building materials, and urban form and traffic and humidity and wind. The video does not claim that the cooling or electrical systems of Dubai have already failed. If you value documentaries that look past the skyline and examine the systems keeping modern cities alive, please subscribe. Because the most important part of a city is often the machinery you were never meant to notice.